Alright, looks like we're live. Hello everyone and welcome to yet another recreational programming session. How about that? So let's make a little bit of an announcement, and after the announcement we're gonna do a little bit of programming. As usual. So, a red circle live on Twitch, and what we're doing today we're making compiler yet again. So let's give the link to the Twitch channel, twitch.tv/Tsodim, and I'm gonna ping everyone who's interested in being pinged, and there we go, the stream has officially started. The stream has officially started. Hello everyone, welcome. Hello Joffa87, welcome. So, today we're gonna be continuing developing Porth. And today we're going to be working on a very special feature that I was contemplating to implement, right? So because I wasn't sure if I really want to have that in the language, and like that kind of breaks the language in a backward incompatible way, but it's in development, in the development anyway, so who cares? So let me start my Emacs from within the development environment, and I'm gonna show you. Hello everyone, welcome. Hello Lance Rap, I Good Duke, 10 Magical, Goose Beer, Bet, hello, welcome. So in Porth, let's actually write a simple hello world. Oh, by the way, this is actually very important. Recently I've made a very difficult technical decision. You may notice that in the source code of Porth, there is no porth.py anymore. So, my idea was the following. I was thinking that I'm gonna actually keep both of the implementations, right? The Porth implementations and Porth.py implementation, and then I would on the stream develop in Python, and then backport that to Porth.porth. But after estimating like how much work it will take, I decided that the time has finally come. I think the time has finally come, and I nuked the Python version. So from now on, I'm going to be developing Porth in Porth. So the agenda point of the Porth being self-hosted is finally fulfilled. Can you fulfill agenda? I don't speak English anyway, but you get what I mean. So yeah, so it's finally self-hosted. Right, it was actually a pretty big step in the development. I think it took the longest so far. Any of the previous steps were actually super fast and super easy. Self-hosted took like a lot of time. So the next step in the agenda was making it optimized. But I think I'm not ready yet to make it optimized. I want to make it a little bit easier to use because it's not particularly convenient language, right? So I decided to put another point in here. So basically make it more or less close to inconvenience to see, whatever that's supposed to mean, right? So I kind of know, like I kind of have a criteria in my head. So I basically have a bunch of features that I want to implement for that language before I go into optimization. So we're going to first do those, and then we can go into optimization, cross-platformness, and so on and so forth. So because this language is self-hosted now, you can't just right away start using it. You have to bootstrap it first. Right, and to bootstrap it, we have a special folder in here called Bootstrap. It's a very important folder, by the way. It contains the assembly files, precompiled assembly files of the Porth compiler. Right. So, and we have two versions for FASM and NASM. There's not that much difference between them, right? Because the FASM and NASM syntax is pretty much the same. It's just like the difference between the declaration of segments, sections, and the entry points and stuff like that. So, and in the README, there are instructions on how to bootstrap the compiler, right? So let's actually find them. So this is how we do that with FASM. First, you have to compile the FASM executable. There we go, you just compile the FASM executable, and this is pretty much it. You have a FASM executable, but unfortunately it's not, doesn't have executable permissions yet. So the first thing you have to do, you have to change the permissions to make this entire thing executable. And there we go, you basically have a bootstrapped compiler. There we go, so here it is. And then you can use that compiler to compile the compiler. There we go. So this will actually create the version with the NASM, but you get the idea. So unfortunately, our compiler currently does not rename the output executable to its proper name, so you have to do that yourself. But soon I'm going to fix that as well. And there we go. So we just bootstrapped a compiler. So this is how we do that. That's pretty cool. And now you can start developing things. You can write hello world, hello.porth. Let's include the standard library, and then put something like hello world in here, puts. So this is basically a hello world. I'm gonna compile it and run it simultaneously. There we go. As you can see, it printed hello world, and always, as usual, I forget the new line. So let's put the new line, and there you go. So that's pretty cool and all, but as you can see, one of the sort of, how is that specific of Porth, right? Specific of Porth is that it doesn't have an entry point, right? It's sort of like a scripting language, but it's not a really scripting language, right? It's a compiled native statically typed language, right? But it still doesn't have an entry point. It doesn't have any main function. So essentially, it takes all of the instructions as all of the instructions outside of the procedures and executes them in the main function. So the way it works, it is actually pretty dumb, not gonna lie. Right, so essentially imagine that you have something like this, then you have some sort of a procedure in here, let's say foo, right, and in foo procedure you're gonna take 69 and print it, and then you may have something like foo in here. So as you can see, you have some code. You have the procedure definition, and then you have a procedure call. Let's actually call that procedure 2 times, right? And if you try to run something like that, first it will print hello world, and then it will print 69 2 times because you called foo 2 times, because you're 2-time champion. All right, so if we try to do that, as you can see, it printed hello world and 69 2 times. So exactly as I said. So essentially how it compiled it, what kind of code it generated, this is actually very interesting. So what it does, essentially, it generates intermediate representation, right? So basically a bytecode of the intermediate representation. So I think the compiler has an ability to actually show what gets generated if you use subcommand dump, but since we're including the standard library, it actually includes the bytecode of the entire standard library, so we have to kind of get rid of the standard library first. So let me just remove that, and without the standard library we don't have puts, so let's actually replace this thing with 420. So we're gonna have 420 69 69, right? So it's a little bit easier to work with because it doesn't require standard library and it generates a pretty small footprint of the intermediate representation. So let's take a look. 420 69 69, it even compiles really fast. You see, it doesn't have to handle the standard library. That's actually very fast. Look at that. I really like that. Generation actually takes the most time, even though, well, it's because it's NASM. Anyway, let's take a look at the intermediate representation. So this is how it looks like. This is a very interesting intermediate representation. So let's actually compare that things side by side. So the first command of the intermediate representation is actually op start. It's op start. So the command at the address 0 is always the start, and it indicates that this is where the program starts executed. So it doesn't really do anything, but it's sort of a useful marker during type checking. We'll get to that a little bit later, but the type checking actually looks at where it started type checking things, and it uses op start as a marker to indicate that, yeah, so we're type checking the main program and not a sub-program. So the next thing is push int 420, so here is this thing, and the next one is an intrinsic print. So as you can see, it literally compiled these two things into separate instructions. No procedure yet, by the way. Then we have a very interesting instruction called skip procedure, which is located in here. And then prep procedure. So skip procedure is an conditional jump that jumps to the address in the operand. So address in the operand is 8, so it will jump in here. So essentially, it's a single pass compiler that just iterates through the code once and generates the sequence of instructions without like looking back or iterating several times. And to achieve that, it basically introduces a skip instruction which skips the execution of this procedure. So the program will start executing from here, it executes that, then it encounters the procedure, and because of this instruction in here, it will skip the procedure and continue executing here. And then it will call the function, so it will go here, executes that, and then to the end and goes back, and so on and so forth. You see, so the body of the functions is actually intertwined with the main program. Right, so to have no main function and still keep the compiler simpler, this is what I had to do. Does that make any sense? Right. So this allows to make the compiler super simple because you can just iterate the source code and just generate on the fly, right? And you don't have to look back, you don't have to gather all of the procedures, you just like generate it in one pass. And that creates like kind of an ugly program, right? Because it had to skip a lot of things. In fact, when you include the standard library, there is a shit ton of procedures in here, like a lot of procedures. And the first thing any porth program does, it skips all of them, right? Because execution starts at the top of the standard library, and the first thing, it just have to skip all of them. It just like literally goes at runtime and skips all of them until it gets to something that is executable, right? And for the longest time, I thought that to make it otherwise, you would have to implement like a two-pass compiler, right? You would have to implement two-pass compiler that on the first pass will collect all of the stray operations and put them into the main function, right? And then on the second path, it will generate all of the procedures and then the main function. Right, but then I noticed that when the program becomes sufficiently complicated, right, like for example the compiler itself, this is what I usually end up with. I end up with a single stray operation which calls to a main function, and then I do all of the necessary work in the main function. Which leads me to conclusion. Why not just disallow all of the stray operations outside of the procedures, right? Disallow all of them, and then just get rid of the skip operation, and just generate as it is. And then during the generation, just set the entry point to main. That way, the compiler is still a single pass compiler. It's very simple. You get rid of a single operation in the intermediate representation. And yeah, it just like overall becomes simpler, right? So, and this is basically the goal of today's stream. So in today's stream, we're going to try to introduce the entry point, the main function, and then we're going to disallow anything outside of the procedures, right? And basically this language is going to be a little bit closer to C, right? So you have to define a main procedure and then start working in the main procedure and stuff like that. Can't you collapse consecutive skips? I have no idea what you mean, but collapsing sounds like something that you have to implement on top of the existing thing. What I'm proposing is actually removing things, reducing complexity. Right, you see, when you have a particular problem, you have two ways that you can solve that. You can basically put more complexity on top of the problem, trying to work around the problem, or you can basically reduce complexity to the point when the problem does not exist anymore. Right. So collapse something, you're proposing implementing some code that performs the collapsion or collapse or whatever, how do you call that? I don't know. So basically you're proposing the way of adding more complexity to the compiler. What I'm proposing is actually getting rid of the complexity to the point that you don't have to do anything. You see what I'm saying? And like reducing complexity is always better because adding more complexity fixes the current problem, but it introduces more problems later, right? So if I implement something that collapses something, I still have no idea what you mean, by the way, but let's assume that I do. If you introduce something that collapses something, this is a piece of code with its own bugs that I have to maintain. If I don't implement it, that means I don't have that piece of code with its own bugs that I have to maintain. I have to maintain less. Does that make any sense? You see, what I'm suggesting, I'm not suggesting to add code. I'm suggesting to remove code. And by removing code, you have to do less in the future. You see, it's actually pretty cool. So, does it make sense? Can you have procedures and procedures? You can have procedures and procedures, but it doesn't really make much sense, I think. Though it's kind of important to notice. Yeah, so right now you could have procedures and procedures, but we have no scoping. So you could define procedure in here, inside of the main, but then you'll be able to use it outside of the main because there is no scoping. And because of that, it's actually very interesting. I think we should forbid definition of procedure inside of procedures, but I think it's already forbidden, right? So if I try to do something like proc foo end, I can actually define it like this, and try to compile the entire thing. So it's support.porth. So definition procedures inside of the procedures is not allowed. Definition should have actually said like defining. Yeah, defining procedures inside the procedures is not allowed, but yeah. But it says for now. So in the future we're gonna actually have that. Right, so we cannot do that, and the current procedure starts in here, so you can't do that for now. But later we can have that. If you have two procedures, one after the other, do you have one or two jumps? You have two jumps. But you can have some stuff between the procedures, right? In that case, you will perform one jump, perform something, and then another jump. So you cannot just like, oh, that's what you mean by collapsing the jumps, right? That's what you mean. We cannot collapse the jumps in that sense because you can have some code between the procedures and it needs to be executed according to the current semantic. Thank you for actually asking whether, well, yeah. Yeah, thank you for this question. This is actually very important questions. What's the difference between puts and print? Puts is a standard library function and print is a built-in intrinsic, which is built into the compiler, and it can only print unsigned integers. And it works without the standard library. Is this your own language? Yes, it is my own language. By sure by collapse, they mean if a skip point to another skip, just merge the two into one skip. Either way works fine though. As already said, that does not contradict to my point of adding more code. That just adds more code. You need to implement an entity that performs that algorithm. That algorithm needs to be maintained. It could be buggy. It's just like more surface area for the bugs. You see what I mean? So every time I say that, like everyone ignores that point for some reason. I don't know why. MCQ8, thank you so much for tier 1 subscription, 17 months of tier 1 subscription. Thank you, and welcome to our Epic Port Club. All right, so I guess everything is clear now, and let's go ahead and try to implement that shite. So we also have another subscription this summer, Grinch, with Twitch Prime. Thank you. I'm sorry I missed it, but yeah, I think like I look at my list of subscriptions and I can see you. Thank you. Really appreciate it. So let's go. So what we're gonna do in here, I suppose first thing we need to do, we need to somehow detect that we have stray operations outside of the procedures and forbid them. That's one thing we probably want to do. So, and then we're gonna go through all of these stray procedures and we're gonna force them to be in the main procedure. All right, so I'm gonna go into the porth, and so we have a function compile file into operations, right? Compile file into operations. And we need to essentially forbid things like token int and I think token word, though we'll have to do something like this, right? So I'll have to copy paste this entire thing. token word, right? So also token word should not be allowed outside of a procedure, and so on and so forth. All right, so I think the easiest way to do that, we literally have a variable that indicates that you are inside of the procedure. It's called inside procedure, right? If you are inside of the procedure, right, if you're not inside of the procedure, we can actually throw some sort of error saying error, integers are not allowed outside of the procedures. All right, so you can also put integers in constant definition, so it's not particularly precise error message. Integers are not allowed at the top level of the program, right? Only inside of procedures, constants, and memories and stuff like that. I'm Yugar. Thank you so much for tier 1 subscription, your first subscription, by the way. Welcome to our Epic Porth Club. So we also have to indicate the location of the token, right? So, and in here we have this thing, so I have to take, excuse me, token location, and I have to print that token location. There we go. So after that, I think I just have to exit with non-zero exit code. So that's the only thing I can do. All right, so let's actually give it a try. I'm gonna just create a foo.porth. I'm going to include the standard library. As far as I know, in the standard library, we don't really have any stray things, right? We don't really have any stray things, so it should be fine, but this program should not compile now. Well, I mean, I have to recompile the compiler first, right? And to recompile the compiler, I'll have to use the Bootstrap compiler. So I'm gonna just do it like that. Compile porth.porth. I'm gonna use the FASM generator, FASM Linux x86 64, and once it's done, I'm going to move the output into porth. There we go. So it is compiling, it is doing things, and now I have just porth. So after that, I'm going to use the new version of porth to compile the foo. And it should fail now. As you can see, it says integers are not allowed at the top level of the program, exactly the problem that we indicated. And there we go, here is a 69. So, all right, if I remove 69, it will actually complain at the type checking. Right, so you have a stray word, and the compiler didn't complain, only type checker, because like print wants to have something at the top of the stack. So we actually have to go to more different kinds of tokens, right, and do a similar thing. Right, and do a similar thing. So let me find the next else. So here we have like 4 spaces. Can I just search for 4 spaces? God damn it. Unfortunately, when you search with regular expression, you cannot just say that you're searching for 4 spaces. Yeah, you can also find this kind of stuff, unfortunately. Can I say the beginning of the line? 1, 2, 3, 4, and then else? There we go. Okay, so that's perfect, actually. All right, so this is a keyword, and here is the word. Okay, perfect. So, and in here we can say words are not allowed at the top level of the program. By the way, wait a second. I think I literally have a function for this kind of stuff. Wait a second. So it is called data token type. Is it token type? I don't remember. So something like human token type. Yes. So essentially I provide the token type, right? One of the tokens types, it's a token word, token integer, and then the plurality, singular or plural. And then it will return me the word, like an integer, a word, a string, and so on and so forth, depending on the token type. And also in plural form, integers, words, strings, C-style strings, and so on and so forth. So this is needed, this can be used in the diagnostic error messages, which is rather convenient. So I think I can actually use that. So proc compile file into ops, and literally I can just like take that like this and separate this message. So here we should have integers. Instead, we take the token type. So here's the token type, and I read it as an integer. And then I use a human token type. And if I remember correctly, human token type just accepts the token type and plurality. And in our case, we have to have a human plural, right? Human plural. There we go. And that will just return a string that we can print in here. And let's also align everything with eputs. Maybe we want to align it with eput. Eput. There we go. Cool. So this is the error message now. And basically we can now copy paste this piece of code to all of the forbidden stray types of tokens, and it will actually generate a proper error message. If it's going to be an integer, it will say integers. If it's going to be a word, it's going to say words, and so on and so forth. All right, so let me see. Else? So this is the next one. So this is the word, and there we go. Next one is a string. The same situation with a string. C string and character. Okay, so we don't want to have any of those things in there. Cool. Let's recompile the compiler now with the Bootstrap compiler. And now let's try to run foo. Okay, so words are not allowed at the top level of the program. If I put something like this, it says integers are not allowed. If I say something like hello, hello, it will say strings. As you can see, this procedure works correctly. It gives us the proper name in here, which is perfect. Cool. So, but the question is, can you even compile the compiler itself now? Probably not. If I try to compile the compiler itself, it will say that words are not allowed at the top level of the program. And okay, this one is interesting. So it basically initializes global variable args that is used outside of the main, but I'm not sure why it is done like that. But you can simply just put this thing inside of main and that's gonna be fine, I think. So, all right, so if I try to compile it yet again, so now it says, okay, so there's only main in here. So in the entire compiler, we don't have anything outside of the procedures except one single thing that starts the entry point. And that's kind of the reason why I want you to do all of that, right? Because it's kind of pointless, right? If the only thing that you're going to keep outside of the procedures is the start of the entry point, why not just like do that automatically and just don't allow anything outside of the procedures, right? And even in Python, by the way, even in Python, when the program gets sufficiently large, people start to tuck all of this stray code into procedures and stuff like that, or at least into the entry point of Porth, where you have if underscore underscore name underscore underscore equal underscore underscore main. You know what I'm talking about, right? So usually this like stray code is useful for very small script programs. But once programs get sufficiently large, you really want to separate your code into like procedures, into like the self-contained unit. So, and it just like makes sense. It just kind of makes sense, I think. So I'm looking at the chat. Maybe somebody asked interesting on-topic question. All right. So I suppose the next thing we want to do, we want to automatically generate this call to main, right? We want to automatically do that. So let's actually see how we can do all of that. Porth.porth. Already import.porth. So I suppose it has to be done at the level of the code generator, right? The code generator had to, like after generating everything, it has to simply find the main procedure or throw an error if the main procedure was not provided rather. And then just create a call to that procedure. So right now we have two generators. The first generator is for FASM and the second one is for NASM. So let's actually work with NASM because it's sort of like a default generator, right? So because if I forget to switch to FASM, it will just gonna be fine. So let's go to function generate, generate op intel. Oh yeah, they actually share a lot of code. Yeah. They actually share a lot of code because they are so similar. Okay, so this is how we generate this entire thing. So here is like bits, segment text. Here is the global thing. And now this is where we can do all of that. Okay, here it is. So here is the entry point to the program. We're generating the entry point to the program, and then we're generating assembly code for each individual instruction in the intermediate representation, and then we're closing the entire thing. So here is an idea. What if we start generating all of that before the entry point, right? So essentially we generated like the segment text, then generated all of the assembly for the instructions. This is the end. And then in here, we're going to simply perform the call to the main, right? But to call to the main, we have to know its address, right? So we'll have to do something like call address, and then we'll have to provide the specific address. So to know the address of the procedures, we have to look it up. We have a special thing called proc lookup. Yeah, proc lookup by name. So we can just literally look up. Do we have a main procedure? This entire thing returns a pointer to a procedure structure. And a procedure structure consists of several fields. It has a name, address, exactly what we need, location in the source code, essentially file path, row and column, the contracts, the type checking contracts, what types goes into the procedure, what types go out of the procedure, whether this thing is inlineable, and the size of the procedure in instructions. So this information is useful. This information is useful in case we're inlining things, right? So this is basically the definition of the procedure, the internal definition of the procedure in the compiler. Right, if such procedure does not exist, this thing will simply return null, right? So let's actually do something like this. Let's duplicate the procedure and just check if it's equal to null. If it is equal to null, we're gonna just simply throw an error. We don't have any choice, right? So error, a main function was not provided. There we go. And then we're going to exit with non-zero exit code. If the main function was provided, right? If the main function was provided, we can just call that function. As simple as that. 1, 2, 3, 4. Call address. I'm going to do out fd64 puts. So that's essentially this thing prints the string to the output file, right? So we have a variable that contains the file descriptor of the output file. We are dereferencing that variable, reading the integer, and then we're using it to actually print that string into that file. So that's essentially what we're doing in here. So the next thing we need to do, we need to get the address of the procedure. So I duplicate the procedure structure, then I access its address. And then I just need to print it as the unsigned integer, fput_u. I think this is how we do that. And at the end of all of that, we have to do something like this. And we can also align all of that by out of d. There we go. So this is basically what we have in here. So that should be it. So here we prepare the program, right? So we take the current stack pointer and we save it into the memory. And then we also take the return stack end and also save it somewhere here. So this is like, I don't remember what exactly that means, but it's some technical information that is important for like two stacks, for the data stack and for the return stack. If I need to, I can kind of recall what it does, but right now I think it's outside of the scope of what we're doing. Right, we call to the main, and then after main is done, we exit with 0 exit code, and then we prepare this segment data. I think that is it, hopefully. Let me try to compile the compiler now. Is it going to compile? Words are not allowed. Okay, so here's an interesting thing. Now I need to sort of like comment it out because it won't even compile without this thing. Did it work first try? Okay, it takes some time because it's NASM, but alright, so maybe I should also implement that for FASM, but yeah, we'll see. So here is the compiler now, and it doesn't work! Yay! It doesn't work. Wonder why though. So it literally didn't print anything. It literally did not print anything. I know why. Oh shit, this is so cool. Do you guys know why? Do you guys know why it didn't print anything? This is so fascinating. Because I compiled it with the previous version of the compiler that didn't set main as the entry point. You see, the previous version of the compiler didn't allow these stray words, but it also didn't set main as an entry point. Right, I removed the main, it compiled that version of the compiler, it compiled it perfectly, but it didn't set the main, so it just does nothing. It has a bunch of code of the compiler, but it just like never executes it. This is so funny. This is the beauty of the, well, beauty, I suppose. It's a blessing and the curse of the self-hosted compiler. Right, so because you have these kind of situations. So this is very interesting, and we can try to use the Bootstrap compiler, but Bootstrap compiler also will generate the code. It will generate the code that doesn't do anything, right? It will generate the code that doesn't do anything. So first, what I have to do, I have to enable this entry point, right? I'm enabling this entry point and I'm compiling it with the old compiler, right? So, and now we have a old compiler that can actually compile itself. So that can actually compile itself, and it's only on NASM though. Right, but it won't work because words are not allowed at the top level, so you have to now remove it. And finally, you should have a compiler that can compile itself, but also sets the main entry point as the main function as the entry point. So this is very interesting. So it's really mind-bending. It's really mind-bending that you when you start introducing these backward incompatible features into the compiler, it's just like, holy fucking shit. So, and after that, I suppose we can run this thing one more time, and it seems to be working. It seems to be working. That's pretty cool. All right. Isn't that cool? I think it's pretty cool. So it's pretty dank, I would even say. It is truly dank. So okay. Let me see. You can never test a feature which breaks the compiler with a simpler test. Okay, here is the interesting thing. We can work the following way. I think you can always work the following way. Let me see, where is my tablet? Here is the tablet. So you have a porth executable, right? I'm going to indicate that this is an executable with porth.exe, right? So this is the porth.exe. And it's actually turned out very, very big because of everything is so inconvenient. Okay. Porth.exe. Porth.exe. All right, and then we also have something porth.porth. Porth.porth. So this is the second thing. And essentially you can use porth.exe and porth.porth to generate porth.exe yet again, right? So imagine that you want to implement a new feature, right? You need a new feature. And here is the idea. You implement a new feature in the source code, but you don't use the new feature in the source code itself. So essentially, you have a separate test program, right? As you said, this is probably what you meant, right? So test porth, which is written with that backward incompatible feature, right? And you only test it in here, but you can't really use that feature in the old version of the compiler. Because here is an interesting thing. By introducing that backward incompatible feature, you're basically not a Porth anymore. You are essentially a different language. So you have a situation then when your language splits. Now you have a compiler written in an old language and a simple program in a new language. Right. So that's basically what you have. That's actually very interesting. Right. So by introducing a new backward incompatible feature, you literally split your language in two until you get rid of the old language. Actually pretty cool. It's really mind-bending. So I suppose that's what you meant, right? So I guess this kind of feature has to be tested on like small things. All right, that's pretty cool. I guess that's true. If the compiled compiler can then again compile itself, it would be valid, right? Well, yeah, basically. Basically valid. Anyway, all right, so let's continue doing the thing. I suppose I want to add the same stuff to the FASM generator. Let me find the FASM generator. Just a second, I'm just adjusting my setup. Generate FASM. There we go. So here is the FASM, and this is very much similar. So essentially here we have the operations, and we want to move them. We want to move them before the entry point, right? So this is a print, and here is we have this stuff before the entry point, and then we literally do the same thing. Right, we just literally do the same thing between these things. We are looking up the main procedure and then calling to that procedure. So now it should work in both of the generators. Haters. So let's actually recompile this entire thing. It's going to take some time, and this is exactly why I want to use FASM generator. T FASM Linux x86 64. All right, hopefully that will. And that didn't work because I'm an idiot. Yeah, because you're supposed to use this flag before the name. I think because the how to say that, the parsing of the argument stops at the first unknown flag, and that unknown flag is considered to be the file name, but unfortunately it doesn't catch that as an error, which is actually kind of a shame. I think what it has to do, yeah, this is literally how our argument parsing works. This is how it literally works. So it parses the subcommand, and then it starts to parse the flags. It recognizes these flags and it consumes this as the parameter. Then it looks at this thing and it doesn't recognize it as any of the known flags, so it stops parsing the flags and considers this a file, right? And if you put anything after this file, right, so the parsing stops and everything after that is ignored, which is rather interesting, right? So I think it should be thrown as an error. Right, so essentially you can treat that as several files, right? So this could be treated as a user provided several files. And maybe this is something that we can say, right, several files are not supported right now, at least to let the user know that they provided something weird in here, right? So not silently, just don't do anything or do the wrong thing silently. Let me see how we can do that. Where do we parse the arguments? So this is basically the loop that parses the arguments, right? So here we have T, and here we recognize the file, right? Here we recognize the file, and we can take the arguments and we can take a look at the value of these arguments, and if they're null, right, if they're not null rather, I suppose. If they're not null, we can say something like this. Error compiling. What the hell is going on? Okay, compiling compiling several files is not supported yet. I'm not sure if we're gonna support that because I don't really know what exactly should we do in that case. Should we just smash all of the files together and compile them as a single program? Should we compile them as separate programs? Like, I don't know yet. It just like depends on our goals, and I basically have not like decided yet. So I suppose maybe here we wanna do the program was not provided. Then we're gonna check for this thing. And let me try to recompile that one more time. Okay, so not equal because we're comparing the pointers, so we have to use pointer not equals. All right, so everything seems to be Gucci, everything seems to be Tamaguchi, and if I accidentally put these flags after the file name, it should say compiling several files is not supported yet, which kind of makes sense. Maybe. Which, well, it basically breaks on a wrong situation, but the explanation is kind of weird, right? The explanation is kind of weird. Make sure you did not accidentally put any compilation flags after the compiled file. Right. So that's actually a little bit better, I think. Right, because we kind of know the situation in which this could happen, so we can kind of like guess what the user is actually doing. Like, make sure you didn't accidentally put any compilation flags after the compiled file. Or rather, make sure, oh, god damn it. What the hell is going on? Make sure to put all the compilation flags before the compiled file. I think it's a little bit more descriptive. All right, so if I try to compile this entire thing, it seems to be working. And if I go in here, well, I mean, I probably have to do that one more time, several times to actually, well, did I forget to save that thing? Am I an idiot? Why this doesn't work? Like, what? Yikes. Let me try to revert this entire thing. Yeah, there we go. It's kind of weird. I don't really understand that. Oh, wrong. Okay, I'm an idiot. I see, I see. Thank you so much. All right. So I have a little bit of a performance anxiety yet again. when I have like a performance anxiety, I've decided to do like stupid shit. All right. Okay, make sure to put all the compilation flags before. All right. So let me try to compile the entire thing here. All right. And several times, actually. Okay, nice. Cool. What I was doing. So, yeah, I wanted to compile the current situation, essentially. I mean, commit. I wanted to commit the current situation. You know what? I think I need to make a small break. And make a cup of tea maybe. And after the break, we're going to continue and probably start simplifying the compilation process, right? Because now we can essentially get rid of the skip procedure, right? We can just straight up remove it and it's going to be fine. All right. So, right. So let's continue. I want to commit whatever I have already, right? Because I don't want to mess it up accidentally and lose my entire progress. So let's create a separate branch. Let's create a separate branch called entry point, right? So port.port require programs to put all of their code in main procedure. You know what, I don't think I need that. It's taking up too much space. Require programs to put all of their code in the main procedure. Cool. So I'm going to push that branch right into the repo, but it's not merged into the master yet, or into the main. I don't remember which one we're using here. So now what I want to do, I want to get rid of the skip instruction, right? I don't think it is needed anymore. So let's see how easy it is to actually remove the code from Porth. Right, writing code on top of the code base is actually quite easy. You can quite easily do that even in dynamically typed languages. But removing code from dynamically typed languages is actually very painful because checks are happening at runtime. But our language is statically typed, but its type system is actually pretty, not really powerful enough. I wouldn't say it's weak, because weak type system actually has a very specific meaning which is not applicable in here. The type system of Porth is rather strong in a conventional sense of strong type system, but it doesn't have too many types. It's weak in a sense it's not really powerful enough. Right, so unfortunately it's kind of difficult to communicate because weak and strong type system, the notions of weak and strong type systems are already taken, so it's kind of difficult for me to explain what I mean. So we have only 3 types, but those 3 types are strong. So that's basically what I mean by weak, type system. B312, thank you so much for tier 1 subscription. I hope I pronounced nickname correctly. Thank you, and welcome to our epic Porth club. Okay. So yeah, let's see how difficult it is to remove code from Porth. Right, so skip procedure, I'm gonna right away just remove this entire thing and see how the compiler will tell me and in which places this entire thing is broken. All right, so compiling, okay, so thank you so much for reminding me about that. That's very important. I'm really happy that I decided to actually implement that feature. Okay, static assertion. Okay, so here we need to remove this skip proc. Right, so it's gonna be 12, 19. Skip, let's remove that. Next one. In the code generation. In the code generation of our nation, we also don't need to have this thing. So skip, yeah, let's just go ahead and remove that. Unknown word skip. Okay, so where are we? Where are you? So if I go back into proc, introduce procedure. I think I know what it is. When you encounter a procedure, we just call this function and it pushes things like skip procedure and prepare procedure in there. Right, so this is actually very interesting. Okay, so what do we do in here? We pop the ID, some sort of the address from the block stack. We have a special stack that keeps track of the blocks, which is quite important. Then we push the operation, skip operation, onto the into the operation array. But we don't consume whatever we actually got in here, or do we? I'm not quite sure. I think... yeah, I think in here I can just remove this entire thing, right? Because like we don't have to push that anymore at all, so we can just like go ahead and remove this entire thing. Okay, unknown word skip proc. So OP prepare, I think this is in closing. Yeah, I think it's in closing procedure. This is rather interesting. This is in closing procedure, and then yeah, we in closing while do. Huh, that's actually pretty cool. Since we have a procedure called introduce proc, maybe we should have like a symmetrical procedure to enclose proc, and we're gonna put all of this code there. I think that will make a lot of sense. But maybe a little bit later. But maybe right now. Why not? I'm just too afraid to actually touch that. Anyway, so let's go ahead and take a look at that. So here we pop the address from the block stack, and we're finding the operation in the operation array. And here we only duplicate it just to check if it's equal to the skip, but we don't consume it. So this thing kind of introduces a block, but it's not indented properly because I actually wrote that code way back when I didn't develop this sort of pattern of, forming blocks that push something on the stack, then body that handles those elements on the stack, and then drops them at the end of the block. So I usually indicate that with some sort of indentations, right? All right, so usually like everything after this block is indented a little bit, indicating that this is like we're opening the block and then we're just referring to the things inside of that block. Okay, so we're just checking the current procedure. Then we take the procedure counter, subtracting 1. So that means we look at the last defined procedure, right? And in here, we take the amount of operations and we start it to the address. Okay, so that kind of makes sense, and we do that just to compute the size of the procedure. So this is needed to compute the size of the procedure. Might as well actually put something like this: compute the size of the procedure. I think that's going to be useful. Then we push the return, and this is where we kind of consume the operand. I think this is where we kind of consume the operand, so we just push. Yeah, okay, so this is the reason why we do all of that. So here we acquire the skip operation, then we push whatever we need to push to finish the procedure, and only then we assign the address to the skip, because without these operations, you can't fully skip the procedure. I see. So we're supposed to get rid of the skip in here. What I need to do, I need to get rid of this thing, and I also need to get rid of this thing, right? So that kind of fully gets rid of the skip operation, I think, hopefully, if I fully understand this code. Right, so here we encounter end for the prep proc. We set the size of the local memory. We check if it's inside of the procedure. We don't allow defining procedure inside of the procedure. Well, it's basically assertion, right? So we always expect to be inside of the procedure. Then we calculate the size, then we put the return address, then we clean up all of the local memory, and then we say we're not inside of the procedure anymore. Okay, so that makes sense. Cool, let's try to compile it yet again. So what's the next one? A skip procedure, it's... Oh yeah, so it's unreachable anyway, right? So it's not needed anymore. It's not unreachable anymore, it's literally impossible, because it doesn't exist. Okay, so here is the type checking, so we can now also remove the type checking. Oh, by the way, so the type checker had to actually follow all of the skip instructions. It had to follow all of them. Now, if we get rid of all of them, type checker doesn't have to follow them. So maybe it will become a little bit faster. Maybe, we'll see. We actually time like different phases of the compilation. We can just compare them before and after the feature. I think that's actually pretty cool. So maybe that will even speed up something. All right, so what do we have in here? So 20 and skip. I think I forgot to decrement this counter. And that is actually it. Would you look at that? We get rid of the compiler, but can it recompile itself now? It cannot. That is very interesting. So not enough arguments is provided for this thing. Expected 1 but got 0. All right, this is very interesting. So it didn't get any arguments. So what if I put this thing in here? Right, it says that there is at least one argument in here. It's that one. But if I remove this thing, it is not available anymore. Why would it do that? I think I know what's going on. God damn, bruv. Okay, so just a second. Do I still have that small program that I used to test things with? Let me actually rewrite it one more time. So this is gonna be, oh boy, what was I think it was like 420. Print 420, then proc full in 69 print full. If I try to now sort of like dump this entire thing, full the fourth, integers are not allowed. Oh yeah. Goddamn. So I have to do that in proc main. Completely forgot. Okay. So first we have prep proc, right? So this is that thing. So essentially, I know what's going on. We're type checking starting from the beginning in here. Right, so the type checker literally encounters prep proc, and I think type checker should not encounter prep proc. I see. So let me actually quickly fix that. Where do we do that? Proc type check program in here. So here we're starting the type checking of all of the procedures, and then we're starting the type checking of the entire program. Right. So we don't have to do that anymore. We don't have to type check the entire program because the program starts at main. Yes, so by just type checking all of the procedures, I'm already type checking the main program because it's one of the procedures. All right, that makes a lot of sense. Let's try to recompile this entire thing, and I think we won't be able to recompile it because we busted. Okay, so we have to go back to Bootstrap compiler, right? So we have to go back to the Bootstrap compiler, and we won't be able to compile it with Bootstrap compiler, at least for the second time, because it needs the main entry point. It needs the main entry point, right? Yeah, it needs the main entry point. So essentially what we'll have to do, first, we'll have to uncomment this main, right? Then compile it with a Bootstrap compiler, right? Then go back into new compiler, which will not compile it because words are not allowed, so we have to comment it again. And now it should be able to compile itself, and it should be able to fully type check itself. All right, and now we don't have any skip an instruction in the intermediate representation. Right, I think I achieved that. Yeah. It's pretty cool. So, and now if I take a look at the dump of foo, right? At the dump of foo, we don't have any skips, right? So there's only prep proc, but no skips at all. There's also, oh yeah, here are the returns. And if I try to run the entire thing, it actually runs everything. Okay, so we basically removed one of the instructions from the intermediate representation of the language, simplifying the instruction set of the intermediate representation. Banana Wave YouTube, thank you so much for 10 months of tier 1 subscription. Thank you. Really appreciate that. Will removing type checking for the whole program affect things that can be outside procedures like memory? Memory definition does not introduce any instructions into intermediate representation, so no. All right, so let me see. What's the next thing? Since the program starts at main, I don't really need OP start instruction anymore. Right. So the reason why I had an OP start instruction is very, very interesting. I have a procedure called type check program from, right? And essentially you can start type checking something like some chunk of the OP array, of the array of the instructions of the intermediate representation, starting from a particular address. And that is used to check the blocks, and there is only like 3 types of blocks that we're checking, right? The first type of block is the whole program, right? We're type checking the whole program as a single block. The second type of block we're type checking is a procedure. We type checking the procedures as small subprograms, which they are actually. For quite some time, functions procedures were also called subprograms in some languages. And another type of block we're type checking is loops. Right. So, and when you type check in loop, you also provide outs. So essentially you provide ints. Here is the current state of the stack. You start from here, and this is what is expected on the stack, right? So, and to generate different kind of error messages, we used different indicators of the starts of these blocks. Right. If we encountered the stack inconsistency at the end of the type checking, like insufficient data or too much data or unexpected data, depending on the type of the block, whether it's a start of the program or it's a start of the loop or it's a start of the procedure, we would generate different error message for these kind of types of blocks. And that's why I had this sort of marker. It's not like a real instruction, it's sort of a marker to generate different error messages. Right, and since I got rid of the stray code outside of the entry point, I don't need it anymore. I can remove second instruction from intermediate representation. You see, this is the path of removing complexity rather than adding more complexity. Right, so I'm just basically removing instructions until the point where it's not a problem anymore. Right, so it just becomes simpler and simpler. Yeah, so let's go ahead and remove the OP start. But before I do that, I think I'm gonna commit whatever I have in here. So does it make any sense? Does my explanation of type checking make any sense? Hopefully, because the type checking in Porth is rather complicated, but I'm trying to make it more or less approachable. Right. So the type checking the stack-based languages is kind of difficult. It's a little bit more difficult than the classical expression-based languages for some reason. All right. So remove op skip proc instruction from intermediate representation. I'm going to push that right into the repo. All right, so port.port. OP start, and let's go ahead and simply remove the OP start and let the compiler do the work. Right. Okay, so this is going to be 18, and there we go. I might as well just do it like that. Cool. Next one. So this is the generation 18, and as you can see, since it's a marker, we're not even doing anything, right? It's literally useless instruction, and I got to the point where I just don't need it anymore. That's very useful. That feels so good to remove the code. Okay, so what's that? I think this is type checking, or is that a compilation? I think this is a compilation. Yeah, wait. Why are we doing exhaustive OP type in here if we are looking for... Well, I guess it makes sense in here, right? So yeah, so we don't handle the OP start in here, but I want to be reminded about that place when I add a new type of the instruction, because this is probably something that I may want to handle in here, but not really. We'll see. Unknown word OP start. Okay, so when I start compiling the program, the first thing I do, I just put OP start at the very beginning of all of the operations. Now I don't have to do that anymore. Cool. So here is another thing. So this is, I presume this is a type checking. And again, in the type checking, we don't even do anything useful. So bye-bye. All right. Anything else? Unknown word start. Okay, so this is where we're generating. Yeah, and for half of these situations, OP start would be even unreachable. You can't have unexpected data on the stack at the end of the program because there should be no data at the end of the program, right? It would be unreachable. So it only further proves that this was a useless operation. But it was kind of needed in one specific case, which is completely eliminated by entry point, right? So yeah, I think we're on the right track. The rule of thumb is when you're removing unreachable branches, that means you're removing the useless code, right? If you can remove them, because sometimes you cannot remove the unreachable branches, right? But if you can, you're finally removing the useless code. But this is just a rule of thumb. It's not a rule. It's not a hard law. It's just a rule of thumb. Another unreachable block. There we go. Okay, cool. And that's it. Can we recompile itself ourselves? Did it become just faster? All right, so it's around 0902. 08, okay. All right, let's actually remember these stats. And let's take a look at the old version of the compilation, right? So I'm gonna just enable this thing back, and I'm gonna use the Bootstrap compiler for all of that. Bootstrap porth. Damn, I think we became faster, didn't we? Just a little bit, just a tiny bit. All right, so if I take a look at this thing, yeah, I think at least compilation became faster, right? Because it was consistently, compilation was consistently below 1 second. Now here, sometimes we actually go above 1 second. I don't know, maybe. Maybe not. Maybe it's just a fluctuation. Also, I'm streaming right now, so like streaming greatly affects everything, so maybe there is not that much gain. So here I'll have to comment it out. There we go. And now it's 1 second. Okay, it didn't affect anything, but it simplified the code at least, right? So, and that's what I was going for, right? The performance speed up would be a nice bonus, but it was not the goal anyway. The goal was to simplify the, the compilation process and the code as well. All right, so remove OP start instruction from the intermediate representation, and I'm going to push that right into the repo. And I think I'm kind of done with this entire thing, but not really, because we also need to fix the tests. And as you can see, all of them are currently broken because none of them have a main entry point. Right, so this is how many tests are broken. 42 broken tests. All of them require the fix of set reset, and the fix is as simple as just like doing something like this. So probably I don't want to do that on the stream because it's extremely tedious. Right, I just like have to go through all of the broken port programs and introduce the entry points to them. So yeah. But yeah, I think we did it. I think we introduced the entry point that simplified the internals of the compiler and made it a little bit more tight, a little bit more tidy. And yesu, kawaii freaking desu. I've got a sub. Thank you so much, Confix21, for tier 1 subscription. Thank you. Really appreciate that. Though we have a little bit of time, but I don't know. I'm a little bit tired today, so I think today's stream is going to be a little bit short. So let me see if we have any interesting questions in the chat. All right, so I guess that's it for today. Thanks everyone who's watching right now. I really appreciate that. Have a good one, and I see you all on the next Zuzin session, where we're gonna implement something else. Maybe it's gonna be yet another port feature. Maybe it's gonna be some silly project that I want you to explore for some time, like PNG parser. We'll see. We'll see. And let's maybe raid somebody. We haven't raided anyone for quite some time. Is anyone streaming anything interesting on software and game development section of Twitch? Do we have any epic cooders on the cooder section of Twitch? I don't know. Who's streaming? So, software and game development section of Twitch. Nobody asked you. Twitch. What the hell is going on Twitch? Come on. Jai, we already raided Jai multiple times. I don't know. All right, I tried. So, thanks everyone for watching. See you all next time. Love you all.